Nuclear fusion is the fusion or the joining of light nuclei to form a heavier nucleus. And when that happens, some of the mass of those light nuclei will be converted into energy, which is then radiated out. And this is what happens in stars and in the sun, for example. And mainly it's going to be hydrogen fusing with other hydrogens until eventually they form a helium nucleus. But for our example to look at here, I think we'll start by looking at a helium fusion. So helium has got 2 protons and 2 neutrons. So here's one light nuclei. Let's have another helium, another 2 protons and 2 neutrons, and these fuse together or join together to form, and in this case 1, 2, 3, 4 protons, 1, 2, 3, 4 protons are left, and 1, 2, 3, 4, 1, 2, 3, 4 neutrons. That, if you look that up in your periodic table, would be beryllium. So we've got helium, 2 protons, and 2 protons plus 2 neutrons is 4, meets or is fused with another helium, and that forms, in this case, it will form a heavier nucleus with 4 protons. And if you look that up in your periodic table, the element with the atomic number 4, or the number of 4 protons, is beryllium. And here we've got 1, 2, 3, 4, 5, 6, 7, 8 protons plus neutrons. So there we go. And while that happens, there's actually a small change in the total mass. So the total mass of these two doesn't quite add up to the mass of these two. And there's some quite complex physics involved there, but that mass, or that difference in mass, is converted into energy. So I'm going to add plus energy. And it's that energy which is radiated from stars. So to summarize, if you were to ask about this or asked to describe this in an exam, nuclear fusion is, and our notes would be, the joining of 2 light nuclei Remember, nuclei is just the plural of nucleus, and that forms a heavier nucleus, a singular, and while that happens, some mass is converted, or some mass may be converted into energy of radiation, or energy that is radiated out. And that's really all you need to know about nuclear fusion. Now, you might have in a question a different fusion drawn, but you're just looking at this fact: 2 light nuclei, you have your 2 smaller ones on this side. They might be different, might be a helium and a hydrogen, and you'll have to think about what the product will be. But there's 2 light nuke ones fused together to form a heavier nucleus. Now, the thing is, to get this to happen, you need a whole lot of pressure to be able to squeeze these 2 light nuclei together. So this is why it occurs in the centre of stars, because there's a whole lot of pressure there with all the gravity of all the other hydrogen, helium, all the other particles squashing it together in the centre of the stars. But there's nuclear fusion, and if you're asked to describe it, you should be mentioning these 3 key points. So this, the joining of 2 light nuclei to form a heavier nucleus, and you've got this idea: some mass might be converted to energy.